Hey guys, just wanted to make a video about reflections of metallic objects in Lumen. First thing is just I want to show you what's going on here. So you can see that in the scene we have metallic objects that are casting reflections uh, that look a little bit better than, at least I think so, than you might be familiar with in Lumen. So there's a couple of things that I've done here to get this result, but let's just go back in time a little bit. So I'm going to disable the switch here. So this is probably more what you're familiar with when you're using Lumen with hit lighting in particular. Whenever you're looking at a reflective object, if it fails to do a screen trace, it just appears pitch black. And if you are using surface cache, what you get is this, where the base color shows up in this kind of low detail appearance and nothing else. So what I've got going on here is essentially an override that replaces that result with a cube map. So here's the surface cache, which looks marginally better than the raw diffuse. And then if you can switch over to hit lighting, for those with hardware ray tracing, you get actually a pretty good looking result. So there's only a single bounce beyond that. So you can see that we have this sphere bouncing off the mirror, hitting the sphere again, but that's it, right? It can't do any more than that. And the reason is because this technique is using a baked cube map of the scene, and that's essentially acting as a fallback for when the surface cache or hit lighting is showing up. So what that looks like here, I'm just going to bring in this sphere as kind of a debug demonstration. You can see that when I'm looking at it just in my raster view, it is visually green, but when it shows up in a reflection, any place that fails to get a screen trace, which is visible in green, shows up in red. And so basically I'm using that as a mask to put the cube map in. So you can see there we get the bounce. So what this looks like is primarily driven by the ray tracing quality switch, which essentially will test if it's a raster or a ray trace. So essentially we can tell that if we don't get a screen trace on our reflection in Lumen, that it will fall back to ray tracing, whether that's the software ray tracing against the surface cache or the hardware ray tracing with the hit lighting, and it'll fall back to that. And so with that, we would just grab a cube map and put that in instead of red in this case. However, it's not enough to just put the diffuse in. If you go over to the metal here, and I'm just going to take off the emissives. See that they're still black. So you do need emissive and base color. So if I put the emissive back on, take off the base color, it's need that because it's got the it's, all right. So if we look at this, I connect the base color. I guess it's not particularly noticeable in this case, but this is essentially how it works, and it's not perfect. Like, you can particularly see in spots where it has a screen trace and also the cube map visible at the same time. It doesn't always show that well, but I mean, ultimately, it still looks a lot better integrated in the scene than this does. A couple of other things I've got going on in here. So if I just pull up the full metal material, so here we have the cube map, which is just taking a reflection vector uh, into a cube sample. This is going into the coloration and setting up two versions, one with the ray tracing and one without. So in the ray traced version, we're blending in the cube map. In the non-ray traced version, we are just taking the straight color from the color parameter. Both of those run through a metallic shading node just to give it a little more visual appeal. And this is just so I can turn on and off the effect. This comes down into the emissive, which once again has two versions. The ray trace version has emission coming from the cube map, whereas the non-ray traced version does not have any emissive. Otherwise, our metal would glow, and that would look pretty stupid. Next, we have some controls here to reduce the strength of the emission. This is necessary because in some cases, like for example, darker lighting conditions, the cube maps might glow. So for example, if I just turn off my skylight here, you can see that the cube maps kind of glow in the scene, which doesn't look very natural. So you can have this driven by blueprints or something to reduce the strength of the cube map influence in the scene so that they don't glow unnaturally. And then this is a normal map, nothing fancy there. And this is just a simple gradient occlusion mask, which is designed to apply a gradient. So if I go over to the Lumen overview and look at these silver balls, for example, if I turn off the occlusion mask, you can see that it's really bright at the bottom, which results in like this really bright, almost caustic looking glow on the underside. So we just need to mask out the cube map in areas where there is occlusion, in this case, the bottom of the sphere. So if I bring that back on, you can see that now that's no longer glowing unnaturally. Another thing we have going on here is the control over the emissives through a custom node here. I'm just going to show you this real quick. It's not particularly fancy. This is all there is to it. And what this is doing is it's basically testing if it's a lumen or non-lumen. Let me rephrase that. It allows you to control whether or not something is pushed through to the lumen cards, which allows you to control the way that light is emitting. Because one of the problems, if you're using emissives to drive your cube maps and give them some appearance in the scene, the issue with that is that using Lumen, it naturally wants to apply that emissive lighting into the scene, right? If we just go and put on emissive here, right? Let's put a number in there. You can see that it's actually illuminating the scene, right? Which is great for some things, but we don't always want this to be physically illuminating our space. So what this does is it allows it to be, as you can see, emissive in the reflection without actually outputting the emission into the main here. So the next thing we need to do, so that now that we've eliminated the emission from illuminating the scene, we have to take it a step further and put in another ray tracing quality switch to make sure that the emission is only appearing in the reflection and not in the non-reflected surface. And so that's how we wind up with that result. So essentially all that needs to happen here is you would take a cube map and put that in place of your ray tracing here. So I'm going to quickly show that so you can see what's happening there. And next, you would make the rest of your material here how you want it to. And then let's get rid of the green. There you have it. So it's not perfect. Again, you need to do a couple of things. For example, you have to set up a cube map. You can do that using the scene capture cube, which I've got set up here. And you can get this set up to run a capture periodically. I wouldn't let this capture on every frame. I would either capture a static image once and then render it out, bake it out, and use that. Or if you're going to be in a situation where lighting can change, maybe have it capture a new render every time the lighting changes, so that you don't have unnaturally glowing cube maps. You can then take that, and just got this set up to final HDR color and linear sRGB. So there is another problem that some of you may or may not have noticed, which is that the cube map doesn't exactly match our scene. For example, it's a little too dark in the shadowed areas. So if I, for example, go into path tracing, you take a look at the reflection here, you can see we get a pretty close result to the path tracer, but the ceiling is much darker in the cube map. And this is because the cube map is not using Lumen. To the best of my knowledge right now, there isn't any way for cube maps to use Lumen, and therefore the result that you get from your cube map baking isn't going to perfectly match the scene. And that's one of the biggest issues with this technique. Ultimately, it's not perfect, but again, the idea isn't perfection. It's to make it so that we can have multiple metals in the scene without really breaking the immersion of the scene. There's a couple of other things that you can do that help as well. Obviously, these are nearly mirror polished. This has a roughness of 0, almost no normal map at all. If you bring in just a teeny bit of roughness and a little bit of surface normal detail, this gets to be incredibly hard to distinguish. And again, if we compare this to the standard version here, right, we can see that no amount of normal mapping or roughness is going to be able to fix this with the hit mask, right? If you are using your surface cache instead, this might not be quite as bad with non-mirror finished objects, right? Like this isn't the worst in the world. It clearly doesn't look metallic, but again, if we bring this in, now even with the low quality surface cache, we can get a pretty metallic looking object, in the cases of a non-mirrored finish. If we do bring in, a much sharper finish, now it's not horrible, but it's not great. If we bring in the surface cache, now we get that, right? And if we compare this once again just to our path tracing, we get a really pretty similar great result, right? All that we're missing is that third and fourth bounce, right? This is obviously going to be able to bounce many more times, which we can't see here, but that's not going to be important in the vast majority of scenes, right? This is just trying to get you 99% of the way there so that you don't have a jarring result. So anyway, hopefully this is helpful to somebody. Let me bring up the full material here just to show you. And if you have any ideas about how this could be improved, feel free to comment. I've tried a couple of things that didn't work out particularly well. Like for example, rather than here, this is just a simple mask that goes from black at the bottom, white at the top, so that you mask out the bottom. I was really hoping to be able to use distance fields to control that, but it turns out that surface cache doesn't display distance fields, and you don't get the gradient that you would in the case of using more traditional shading techniques. So there's definitely some improvements that I think could be made to this material. So if you have any suggestions, once again, throw them down. And thanks for watching.